All right, guys. So hopefully it's not a surprise. I certainly don't have. I haven't even started the test. Of course, it's fun. It has to be fun. Even if it wasn't fun, it'd be fun. So I don't know. I can't guarantee tomorrow either. So we'll see. It's always interesting when you have a test to 115 students. You just hope to God all of those students realize it might take a while. I hate not having something done the next time I see students, but I'm just going to have to let that go a little bit this semester with you guys. So hopefully we'll see what I can do tomorrow, but I'm telling you right now, don't bet on it. Okay? So today we're going to do the last section in chapter 3, the functions section. Second? 3.8, yeah. So I've posted the 3.8 homework and the 4.1 homework. So if you guys want to get ahead a little bit, I highly recommend, let me just say this right now, and the homework, if you have old homework you want to go back and work on, that's secondary to keeping up with current homework, right? Because you don't want to try to do 3.8 homework a week and a half after I discussed it, because you're not going to have a clue what the hell you're doing. You want to do it a little more closely tied to the lecture. Does that make sense?
Yes, sir.
Okay, I can take that.
No, I think we'll actually
It's okay. Like it's not like it's not bad. Is the 16 style the same as the 17?
So, guys, we actually have already been doing, guys, we've been doing functions already for a while. We just haven't called them. A function is a special kind of correspondence. So let's start there. If I give you a set of points, I've developed a correspondence between x and y. So for example, if I give you these points, 1, 2, 3, 7, negative 1, 2, 3, negative 4, these together define a type of correspondence. So this could be like person number 1 measures a temperature of 2 degrees. You're up in Alaska during that special time of year. Person number 3 measured 2 different degrees. That's interesting for them. I think they're having some trouble with their temperature measuring device, right? Thermostat. And then a good old person number -1, whatever. So a correspondence, a relationship between the x variables and the y variables. Are you with me so far? Does that by itself make a little bit of sense? If I ask you right now what x variables are used, what would you say in this correspondence? Yeah, 1, 3, -1. Now listen, does it make sense you wouldn't say 1, 3, -1, 3? I'd be like, you already said freaking 3, right? Does that make sense? This is going to come up again in a little bit, all right? And if I ask you what are the x values used, you'd say 1, 3, -1. 3 is used twice, so you only have to call it out once. And if I said what y outputs happen, 2, 7, and -4. I love it. Some of you guys might already realize that relates to something called domain and range. So I'll bring that up here and again in a little bit. Notice there is something that couldn't physically really happen. I sort of made fun of it just a second ago. Could person number 1 and person number -1, I don't know who this poor person is, could they both measure 2 degrees? Especially if it's actually freaking 2 degrees. Are you guys with me? That makes physical sense. You take one reading, And somebody else over here, person number -1 takes a reading, and you both say, oh, it's 2. That's amazing. Now, what isn't physically possible? Person number 3 takes a reading, and it says 7 and -4. I don't think so. You guys get the idea here. So this is a correspondence because it does tell you how the x values relate to the y values. 1 goes with 2. 3 corresponds with 7. 3 also corresponds with -4. I mean, the correspondence doesn't give a shit about, doesn't make physical sense. You with me? A little bit? You guys semi with me? I mean, really what we're talking about right now is just barely mathematical, to be honest. I could ask you how many, tell me the names of your uncles, all right? So you would be, you're willing to share, how many uncles do you have? Oh, God.
2.
Yeah, tell me you have 2.
Put like 20.
So student number 1, you would list off some names, right? Give me some names of your uncles.
Robbie.
Robbie?
R-A-M-I-M-M-M-M-M. Not Robbie. Rami.
Oh, Rami.
Yeah.
All right, I got you.
Oh, God.
I mean, you didn't have to do that, but.
Rami?
Yeah, M-I. That's 1.
And then student number 1, you'd still have another one, and student number 1 have another. Sounds like you'd have several. Are you
2 uncles.
you guys, in fact, instead of saying student number 1, I could put your name. I could ask you, what musical instruments do you play? Personally, mine would have an empty. I would just say none. I don't play any, really. I suck at music. My little brother sucked all the musical ability out of the family into himself. And anyway, it's amazing. Do you guys? So it doesn't have to be a mathematical relationship. It can actually be a relationship the way we think of them. The relationship you have with your uncle, right? There could be that kind of relationship, right? The relationship you have 2 names of uncles. And then you have a list of names of uncles, and you have a list of names of uncles, and so forth. Are you guys semi with me? Okay, so but what we consider to be a function is one where every x value, I love this part. So what's a function then? Function is a special kind of correspondence. And it's the one where it has to make physical sense. Okay. So for example, another way to look at this is 3 seconds after I threw a ball, it's 7 feet up in the air. But also 3 seconds, it's 4 feet below the ground. Does that make physical sense? I keep picking on those 2 points because I want to make this make sense. So what can't happen?
We can't make a function.
An x value can't have more than one y output. Are you guys with me? A little bit? And let me throw something weird out there. Anybody guys ever seen Highlander? Do you know that? The movie or the series? All right. What do they keep saying right before they chop people's heads off? There could be only one. Now the rest of you guys are intrigued. Look it up. Good old Highlander. Movie number 1. Maybe skip movie number 2. But where's movie 3 where they get all alienated? All right. Let go of Highlander if you don't. If you do, you'll get a kick out of this. The official definition of a function, oh boy, is for every input, which normally would be the x's, for every input, there can be only one. There can be only one output. Y's. So if I ask you what size shoe are you wearing on your left foot, and you give me 2 numbers, I'm like, are you wearing freaking 2 shoes on your left foot? Physically, it wouldn't make sense to answer with 2 different possible outputs. Do you guys see what I'm saying? Now give him a challenge tomorrow. I want to see you with 2 shoes on. Are you guys with me with this? This is the best way, and it's sort of close to the reality of what's happening, but it's the best way to kind of look at it as a function. I want it to be able to describe something that is physically possible. So if I say at 3 seconds, where is the ball? You give me one answer. Or else something weird has happened to that ball, somebody sliced it, whee, or something strange is happening, right? Instantaneous transmission. Okay. We'll let that sink in. So obviously, if I give it to you as a list of points, you know what to look for to tell if it's a function. Is this a function? Why? I kind of circled the problem already, right? There's an x that goes to more than one y. So you look for the repeated x's. Does it matter that this is repeated?
No.
Does not matter worth anything. Again, that physically makes sense. Right? Two people can measure the same temperature. I'm not going to go, oh my God, it's amazing. No. But if one person has two temperatures showing up, I'm like, you got to change that thing's batteries, or got to get your eyes checked, or something. Right? Something is not right. All right, let me like that. Okay? Some of you guys look so excited. Okay. But let me give it to you a different way. Let me define a couple more things, some more definitions on the site. So the domain of a function is just a collection of all the inputs you're allowed to use. You can look at it one of two ways, really. All inputs you're allowed to use or that are used. Good luck reading that. Collection of all inputs you're allowed to use or that are used. So you're saying, for this example over here, with this collection of points, let me pull it back over. You guys are still trying to read me? Yeah. This example here, ignoring the fact that there are 3 is repeated, the domain, wouldn't make sense to say that I'm allowed to use. It's just like I see 1, 3, and -1 are being used. So that's why I'm only allowed to use those, because they didn't tell me what anything else goes to. What if I have a 7 here? What's this? I don't know. They didn't tell me. It wasn't used. I'm not allowed to talk about it because they didn't tell me what it would be. You guys, yeah, you guys look sick for stomach. Okay. So a function has every input that we know now is related to the domain going to only one output. So it makes physical sense. The range should be the other part of this definition. The range would relate to the collection of all outputs that occur. I like it. Okay, so, for example, let's go page 59. This guy here, this first one, it's not mathematical at all. But can you tell me, is it a function or not? Why is it not a function? Yeah, there's an input that has more than one output. Now this is not the perfect one to match up, like I said, with that idea of physically possible. Right? Chevy is certainly going to have more than one car that it makes. But this is the more general application of the term of the idea of function. Every input can have only one output. Now here's what about this other one? So this is a slightly different format than what I showed you before, but it's still the same exact idea. How do you think I can make this look like that? These numbers look like this. How could I make these look like this? Yeah, so what are the elements of the domain again? In this, what's the domain again? 1, 3, -1. I like it, right? So 1, 3, -1. What was the range? 2, 7, -4. So 1 went to 2. 3 goes to 7 and -4. -1 goes to 2. You see, so that can be represented in this same format. Is that decent? You guys see that? So this question about the Chevy and the Ford and the Chrysler and all that is not really a different question than this. It's just formatted differently. That's all. So here, domain is the first parts, range is the second parts, or I could just specifically say, here's my domain, here's my range, and not write them as points. What do you do? Hopefully that you realize that's not a big deal. And here's yet a slightly different way to look at it. Whoa, Jeff. This freaky looks like it belongs in biology class or something. The mitochondria. What do you think this first circle is? Circle? My seventh puberty. Domain range. You get all excited. I think I have a growth spurt in that one. No, Jeff, it's too late. Is this a function?
No.
If it's not a function, tell me what part of the domain goes to more than one thing in the range. Does anything do that? No. 1 goes only to 4, 2 goes only to 5, 3 goes only to 5. It's a function, no problem. You guys with me?
Yes.
So if I said, okay, how high off the ground is that book? What'd you say? It's roughly?
An inch.
No, off the ground.
Oh.
Sorry.
I thought you said
Off the table, 0. Unless it's really freaky thing happening, it's levitating.
3 feet.
3 feet. So let's say 3 feet. All right, now, that's at 0 seconds, right? Now it's at 7 seconds. Now, 7 seconds, how high off the ground is freaking 3 still. So who cares if the second one is repeated? That is physically possible. It's if the first one, if I said, all right, 1, 2, now how high is it off the table and off the ground, and you say 3 feet and 20 feet, I'm like, what the hell is that thing doing? What do you mean? Please see what I'm saying. The output being doubled, that there being more than one output does not make physical sense. But 2 things sharing the same output, there's not a damn problem with that. Of course you can get the same, just like you can measure the same temperature even though you're 2 different people. Right? If it is that temperature, you should get that temperature. Shouldn't be an amazing thing. Yeah, like it. So what if I gave a die to every person in here? Right? Ooh, that'd be exciting. Look under your chair, you get a die. And you threw it. Everybody with me? I'm not saying you're going to die. I'm saying a die, a singular dice. Is everybody with me?
Oh, I guess it's a dime.
Die. A die. A die. I said, roll the die. Roll the die. Once. And I say, what do you get? And you say, I got a 2 and a 3. And I'm like, no, you didn't. Right? But if several people say they got a 6, is that freaky? No, of course not. That's completely fine. Again, that relates to the output can't be repeated. I mean, the input can't be repeated. The output can be repeated. It's totally fine. You can have the same results on a die repeated over and over. Not a problem. Okay, I like it. So this is an issue because of Chevy going to more than one thing. This is not an issue because none of these go to more than one of these. I like it. Does this phrase represent a function? Calculating the low temperature of the day. So like today, tomorrow, you get the lowest temperature for today and the lowest temperature for tomorrow. If you said the lowest temperature today was 71 and 72, then it's 71.5. There's not going to be 2 lowest temperatures of a day. I like it. So yes, that's a function. What about listing the children of a parent? No, because there's a parent that could have more than one child. I like it. I like it. Oh, okay. What about this guy? Is this a function here?
No.
We'll say it again. Besides that, no. That's all right. You guys agree with that assessment? Is that a function?
No.
Why? Yeah, 1 goes to 10 and 1 goes to 3 also, so that's no good. I like it. So that is not a function. It's not a function.
That's a big not.
I could have been okay. So that's one idea, that idea of what a function is, definition-wise. That leads to the idea of domain and range. I like it. Now, something, I don't know why they're skipping to this. Let me give you an example of my own here. All this old-fangled technology. It's the most exciting part of your day. Watching my teacher clean his little mic work. Feel bad for you. I mean, I fell off the stage while I was doing this. So, we can do this well enough. Yeah. Oh, it's a little wet still too bad.
What?
Oh, yeah.
That's a nice line.
I like it. Beautiful for my purposes. Somebody help me out. Does somebody see, before I even ask you if this is a function or not, what the domain might be of this thing?
3.
So the lowest x value that's used is -3. Does everybody see that? There's no lower x value that has an output. If I said, what do I get when I have a -4 input? You would go like, I have no idea. And what's the last x value that's used? 3. So the domain would be -3 to 3. Yeah, you gotta love that shit. Domain is x values. So then what do I look at when they give me a graph to figure out the domain? I look at the x-axis. Where's the first output I see? At -3. And what's the last x that has an output? 3. Sometimes I say there's a little dude walking. What's the first time he sees the outputs? -3. What's the last time he sees them? 3. And he just keeps going. Little dude. I desperately trying to make this clear. Yes? Say again? Always. In fact, interval notation is always lowest. And please, dear, everybody realizes that's interval notation there, right? I use interval notation when I want to have everything between two bookend numbers included. Okay. What about the range? What's your take on the range? Yeah, if the domain is all the x's, of course, that are used, the range is all the y's that happen. The lowest y I see happening is -2. And then as I walk along, the highest y I see is 3. Yes?
So are they always brackets, or do you,
No, if I would have put an open circle,
so it's still...
like if this would have been an open circle, that would have been a parenthesis.
Okay.
I like it. So the only reason that those are brackets are because they are closed-in circles. Good question. Now, is this a function? There's a beautiful visual analog of the definition of function. Oh, that's one of my favorite sentences. If every x can have only one y, then what I do is I look to see, is there anywhere that a vertical line goes through more than once? This x value right here, whatever that x value is, it has 1, 2, 3 outputs. Is that allowed for a function? No. So this is what we call, again, being remarkably creative people, math people. We said, it's a vertical line, and it's a test for, so a vertical line test. The vertical line test is the visual analog of the definition. Every x can have only one y. So if it does like this, that x has more than one y. It's got two y's in that case. So if a vertical line goes through more than once, anywhere, it is not a function. I like it. So this is not a function. We found at least one vertical line that goes through more than once. And this would be like, if this is the flight of something flying through the air, this is like time here, then at half a second, or whatever that is, it was at 3 different locations, this one thing. It's a little much to believe, right? I wish, that'd be awesome, to be able to be in different places at once. A la Harry Potter. Yes, the tie job. No. Awesome fans, I don't give a shit. I like Harry Potter and Harry Potter. Alright. So this is not a function. So you can see a problem like a collection of points. You can see a problem like the domain range list. And you can see a problem as a graph. So without getting too specific with points, is this a function?
No.
Hell no. Is this a function?
Yes.
Yes. It gets out of its own way. It doesn't curl back on itself. Right? This is a flight of a rocket at so many seconds. The rocket didn't exist in 2 different places at any point. There's no vertical line that goes through more than once. It's a function. It passes the VLT. VLT. Venison, lettuce, tomato. Ew. It's neat.
I've never had that.
Alright.
Is that beer?
If you're vegan, I apologize. How about it's vegan lettuce these things?
Veggie bacon?
Vegan lettuce. Sure, whatever floats your boat.
I'm not vegan.
Okay. Yes, that's one piece of this, is what the hell is a function and how do you determine when something is a function that they give you in all these multiple ways. Are you guys with me? That's the first part of section 3.8. The second part is going to be more directly algebraic. It's like, now that we know what the hell functions are, how are they represented algebraically? Is there something different about that? Yeah, a little bit. We use this notation called function notation, amazingly enough, f of x. This is read f of x. That is not f times x. Okay. So screw this question whenever they're asking. You just write a little something, cross through that so you don't think later it's talking about yards or any shit. Just cross through that. If I said f of x is x plus 3. Notice what f of x is taking the place of. F of x represents the output for some input. And what letter did we used to use right there? Y. So this would be y equals x plus 3. I just replaced y with function notation. Because what would x plus 3 look like if you graphed it? Can you do it in the air for me? If you graph x plus 3, what would it look like? What's happening? X plus 3. Y equals x plus 3. Yeah, it would be diagonal, right? It has a positive slope. So something like this, if you're doing something like this, that's fantastic. If you're doing this, I don't know. Y equals x plus 3 is a slope of 1. Right? Okay, would that pass the vertical line test?
Yeah.
Yes. So then I can use function notation to describe that relationship. Because it is a function. It passes the vertical line test. You guys with me so far? Now, I know probably a lot of you have already seen this notation, but there might be some of you guys maybe haven't seen it in a long time or think that you have never seen it. The really beautiful thing about function notation is, one thing is, if I just use y's, I couldn't very easily distinguish between these two things. So here's another function, g of x equals 2x minus 5. And I can go really crazy and say h of x equals x squared minus 2. I like it. So I have 3 different functions. I can reference them really easily. If I ask you a question, if I use function notation, you know exactly which one of those to use. If I use y's, you'd be like, let me try and guess which one he wants. So if I say this, what's your gut tell you this should be? F of 2. What does the f function do to something? What is f of x? What is it? Just read it. X plus 3. So f of x is x plus 3. So what does that function do to anything you put into it? Adds 3 to it. That's it. So I really want you to realize the question f of 2 is a substitution question. F of x is x plus 3, so f of 2 is 2 plus 3. It's crazy. It's just, you've done this back in 88 at the beginning, just replacing variables with numbers that they tell you. That's really all function notation itself is on the surface. So f of 2 would be 2 plus 3, which is 5. Can you tell me a point that the function f goes through? A point.
2, 5.
Yeah, 2, 5. So that's another advantage that function notation has, is you can see the input that led to the output. You can see the points in the work you're doing. You don't have to make the whole separate table for it. Okay. So what if I say, what's h of 3? Which function are you using? The last one, yeah, because it's the h function. There's no question about which one I want. And what are you going to do to figure that question out? Yeah, try it. Take a second. Do it. So this says h of something is that thing squared minus 2. So h of 3 is 3 squared minus 2. It's just replace the x with the value that you want. So you get what? Yeah, 9 minus 2, 7. So a point that the function h goes through is 3, 7. Big ass. And again, do you guys remember what that looks like? X squared something or other? What would it look like? Yes. X stuff would be a line. X squared is going to be a parabola. Yes, I like you guys. Is that parabola, John? Yes. I was like saying parabola because it's more interesting. Right. Parabola. Does this pass the vertical line test?
No.
Yeah.
Of course it does. It doesn't go back on itself. If that parabola opened this way, not a function, right? Vertical line would go through more than once. This way, every vertical line goes through only once. So it is a function. That's why I used function notation. That should have been a little giveaway. Must be a function because you use function notation. All right, let's try some more of these. We do number 2 there on page 61. 2 and 3. 2 and 3. Ooh, that's cool.
For the number 2, it's -3 squared, so would you include it like in...
Yeah, this says square x. So you have to square -3. And the idea that when you substitute numbers, you should put them in parentheses so you preserve all the operations.
So it isn't...
That would help you out a lot, yeah.
Positive ones.
So here's when you plug in -3, it just has to go in place. What's replacing x? -3. So replace x with -3. I replace x with -3. People sometimes freak out when there's multiple x's and they leave a lot of x's. No, it told you x is -3. You replace it with -3 everywhere you see it. Because you know what it is. And what do you get? You get 9 plus 6. So you get out. So what point does the g function go through? Negative 3, comma 15. I love it. The g of 1
Is 1 negative 1.
yeah, it would be 1 squared minus twice 1. Negative 1. Do not concern yourself with people that are listening. And try not to take it personally myself. What about, now here, you guys try number 3. And yeah, it is convention to use the letters F, G, H. But to be honest, if you have a profit function, you would use P for profit. If you have a function that counts the number of octopuses you see in the ocean, octopi. Well, I knew either way I said it was going to get interesting. You would use O of X. Does that make sense?
Yeah.
You could use a letter that represents the physical nature of the problem. Right? If you have one that counts the number of times the teacher chooses the wrong way to say a word, it could be W of X. Thank God I don't teach you. So H of 7 would be just 3 over 7 minus 2. 3 over 5. Bam. H of 5 would be 3 over 5 minus 2, which is 3 over 3, which is 1. So I should feel very familiar. You're not as familiar with the notation, but you are very familiar with just plugging shit in. That's really on the heart of it, and on the surface of it, that's all it's asking you to do. Just plug stuff in place of X. Okay, I like that sound.
Wait, for the 4
Say it.
it's just the
4? Oh, I like 4. Good point. What is f of x? 22. Does the output depend on x?
No.
There's no x here, right? So what is f of x always? 22. So what's f of 13? 22.
Oh, I was doing a whole sorry.
What's f of 0? 22. Replace every x you see here with 13. Do it. I'm done. What do you get? 22. You guys see the idea. If there's no x there, x does not affect the output. That means the output is always the same. What kind of line would that be? Y equals 22. Horizontal. Aw, shit. Just remember, y equals 22. Y can't change. It's got to stay 22, so it can't go up and down. It can only go left and right. That's the way you think about it for like 4 seconds. Right?
35.
I guess so. Oh yeah, I love 5's another good one. I like it. This is where people just, I don't know what. Again, is there anything special about the letter X, really? No, not really. Poor little X, dude, but you know. What if X was just one of us? So if H of X, I really apologize. If H of X is 4x minus 1, H of A is 4a minus 1. Before I do the second one, what's H of W? 4w minus 1. I mean, whatever is here takes the place of x. I know right now, you guys, I understand completely that some of you are looking at like the second one, you're going, now it's just busy work bullshit, what the hell? But that kind of thing shows up in basically every math class after this. Being able to handle that. You have to be able to handle that. So what do I do with the second dude here?
4 times a plus 1.
Yeah, so don't do this. It should be 4 times a plus 1 minus 1. So what does h always do? 4 times the thing, 4 times the thing, minus 1. And now simplify it a little bit.
4a plus 4.
Yeah, 4a plus 4 minus 1. 4a plus 3. Like that. That's nice for you, Jeff. You like it. Now, what's really nice is I already talked about this. I already talked about vertical line test. We're just doing things a little bit out of order. Oh well. I already talked about domain and range. I'm awesome. Yeah, so let me give you one more example, and we'll head out a little early. First off, take a minute and try to write the domain. This is page 64 at the top. Let's do part D first. Try to write the domain down. Yeah, part D. The domain relates to which variable? X. So what is the domain going to be? Careful. What's the lowest X that I see being used? So if domain is X, your answer should come from the X axis. What's the lowest X used? -2. So -2. Closed circle, right? And then it uses every X in between all the way up to 5. Let's jump down here for a second. What's the range going to be? Yeah, -3 is the first output I see. -3 up to 2 is the last output I see. Is that cool? I mean, if I give you a graph, domain and range would be really nice. Domain is X, focus on the X-axis. Range is Y, focus on the Y-axis. Now, this kind of question confuses the hell out of some people. I don't blame you. We just did several that I gave you an f of x, and then I asked you to figure out f of 2 and f of whatever. So what's kind of weird about me asking what f of -1 is, where do they tell you what f is? Nowhere. They don't tell me what the function is. They give me something better. They give me something better. They give me all the frickin' answers. They've already done the work. If they plug a -1 in, what number must they have gotten out? And this is where students are still like, how the shit would I know? Well, whatever number they got out, wouldn't that make a point?
Yes.
Then they would put a point there, wouldn't they? So for a -1 input, what must they have gotten out? 2. Do you guys see that? For a -1 input, they must have gotten 2 out. Why? Because they put the freaking point there. All right.
So do we write it as a point?
You just know it. You say, what's f of -1? 2. Can you see the point? -1, comma 2. The answer to this is not a point, because the answer to an f of x question is a number. It's the output you would get. So what's f of -2?
-2.
Yeah, f of -2 is -2. That's what I got. That's what they got out, because that's where they put the point. What's f of 5? 0. Because that's where the point is again. So f of 5 is really asking you what's the y piece of the point that starts with 5. Because they're telling me that x is 5. Why? Because it goes through. Good Lord, John. Get out of there.
This English class.
Be quiet. Because it goes through 5, 0. Just to let you guys know a little bit. So yesterday I went, I'm not going to give you any details, but I went with a friend to court, and it was a very emotional day, and it thankfully came out good, which meant last night we went out and celebrated. So, I'm not trying to give myself an excuse, but yeah. It's been a while since I woke up quite that state. I'm just happy I'm here. Blah, 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 blah. Okay. I think that might be enough for right now. Let me ask you, what about this one?
Yeah, I don't know.
Any x values for which the output is -3.
1.
So where's the output -3? There's only one place. And what x value leads you to an output of -3? 1 does. So this question here is sort of the opposite of these. These say, what's the y piece if the x piece is this? This one says, what's the x piece if the y piece is that? And again, it's all about interpreting the question from math to English for yourself. That's the step that students sometimes don't even realize you need to be able to do. All right, that's play. I'll let you out like 2 minutes early. Don't get used to that. Yes, lab's still happening. Yes.
Can you just fill this out real quick? What my grade is? I'm sure I have like an A in the class.
I don't remember. I'm sure you do.
Yeah, I've gotten 100% on
Exactly. So I mean, that's pretty much. Let's see. Bam.
You
didn't really.
I don't know.
They honestly just can't look at it. I love this. Bah!
Thank you.
Did